Hello, this is third module in our video series of GeoWorks, that is Quick Kinetics module. Utilizing the Tissot-Espitalié model, this module enables the rapid determination of activation energies distribution for S2 and sulfur peaks, which are obtained via pyrolysis conducted at a single controlled heating rate. We know that two reactants react at a rate of time to produce products. So the reaction speed follows the formula as can be seen on the screen, where K is reaction speed or rate constant in Hertz, A is pre-exponential factor or Arrhenius constant or number of collisions per second in Hertz, EA is activation energy in joules per mole, R is the universal gas constant in Jk per mole, and T is the temperature of the chemical species in Kelvin. The speed of reaction is function of the mass of the reactants. Arrhenius introduces his law where EA is the activation energy, which is the energy needed by the molecules to initiate the reaction in joules per mole. RT is the thermal energy applied to the chemicals to the sample in joules per mole. There are two unknown, Arrhenius constant A and activation energy EA. Here we fix Arrhenius constant and calculate activation energy. However, the software also allows to scan activation energy for incremental values of Arrhenius constant. For quick kinetics, we will choose one sample and go to quick kinetics method from the icon like this. Then we can go to compute to kinetics option. We can either give a known fixed value of Arrhenius factor, or we can optimize it in range of the known values. Based on this Arrhenius constant value, the algorithm calculates one by one the generation curve for each activation energy step between the minimum EI, like for example I want to start with 30, max I want to keep 70, with activation energy step of 1 kilocalorie per mole. We can compute options, curve fitting, minimize error and reaction velocities based on whatever fits best on our data. Then we can apply, close, we can go to display and show numerical values like this. So the activation energy has been computed between 30 and 70, like we made sure in the compute option, at each energy step of 1 kilocalorie per mole, the percent of activation energy and the milligram per gram of TOC values. Similarly, we can see results for SO2 peak also. We can choose whether to see pyrolysis hydrocarbon with time in raw data, or in percentage format, or in mg per gram TOC format, whether we want to see the temperature line or not, whether we want to see timeline or not. Here we can see transformation ratio with temperature curve. Here we can see hydrocarbon content versus activation energy curve and the numerical values. We can move from analysis to analysis like this. We can zoom in or zoom out like this, or we can take a snapshot. Put into Word document for reporting like this, or we can go to file and print to PDF document like, and produce details like this, or we can also print it into SVG snapshot. Once we are done with quick kinetics, we can see the hydrocarbon content calculated here, the kinetics parameters, or we can see the sulfur parameters calculated here. This is all in quick kinetics module. Our next video will contain multi-heating rate option of kinetics, which is known as multi-kinetics module.